Okay. Yeah. So I think I'm live. So I start the stream. If you can see the desktop face and my voice, then hear my voice, then that should be okay. All right. So this is not the there's the camera. So this is not the usual Dark Souls stream I do, the blind let's play, but I try to alternate that with a little bit of programming, and this time it's Python game development. And if you want to follow along, I created a GitHub repo on github.com Python user /TwitchFighters, because that's the game I will try to create, and I hope I stay motivated enough, long enough to actually get that thing on the way. So as you can read, it's a competitive multiplayer game designed to play with or through the Twitch chat, and I basically used the stream by Joshua at Joshua Skelly, this lunch break roguelike project as a starting point, but try to go into a completely different way. So he strictly tried to avoid the competitive part, and I want this project to be more like an arena fight of players. So let's see how that goes. Okay, so actually close that off. So I already did some coding, so some basic engine design, and we can just start the program. I can show you what I've done so far. So this is the game window. We have a game window here on the left side, where the level will be implemented, and the players will show up. And then on the right side we have a players list. So if you join the game, then your name and the health bar will thing up. So this is kind of hooked up, sort of. So I can join, and maybe you can see it. There's a little P of my name, and with move, then down, right, I can move in turns of 1 second screen. So this is what we're at in the moment. And yeah, whenever the game window is open, you can try to join the game. Okay, so I will close that off, and maybe I can just show you a little bit of the engine layout, of the code layout. So we start with a file app.py, which reads in configuration, so the Twitch login, all the TDL parameters like screen width and height, frames per second, and then we load in a game class, which is this one, which implements a run method that contains the game loop, and then also scene setup. So we have the game scene and the sidebar scene, so these two windows. I eventually have to refactor that a little bit, but yeah, maybe I do that off screen. And then we have the TDL console setup, so actually that's what you can see as the screen console here. And then also for the interaction with the Twitch chat, we have the Twitch chat manager here, which does basically the parsing of the commands. So it's yeah, commands are implemented as join, leave, and move. I demonstrated a second ago. Okay. And then we have the scenes, a game scene and a sidebar scene. And I think what we can do today is to breathe a little bit more life into that. So create an actual level players can move around in, collision detection and all of that. Yes. Hi Joshua. Yeah. Great that you switched in. Yeah. So as I said, I will try to go a different way than you did, having more of a competitive arena fighting thing than collaborative roguelike event. Okay. Okay. Let me start the program once more. Yeah, I'm also really excited. Yes. Yeah, oh. I really like this this interactivity with the Twitch chat. You know, play games just by issuing some commands. It's nice, and also it's a little fun project to oh, that's not implemented. um, just a little fun project to learn more how the Python language works, and just to get better at programming. It's a very fun way to do that. So this is the game window, the left side, and yes, Joshua joined already. And it would be nice to have a level here. I thought about having it like Bomberman, sort of this grid layout. I think that wouldn't work here, so we just maybe start with a very random distribution of walls, maybe. Yes, we start simple. Okay, so yeah, so Joshua, you can also move around with move. So I already implemented that. Oh yeah, now I'm on top of you. So I can to the right here. And now actually you are gone. You're gone. Okay. Yeah. First bug of the stream. Nice. So you can also add commands to the bot with the normal add command. So we definitely need a bug command. Yeah, maybe we have to look into that first. Yeah, so every scene has an entities list. Basically, all the players get collected in this list. Yeah. Right. So, and when you join, when you issue a join command, it gets parsed by the Twitch chat manager, and that creates a new event, basically a player join event, as defined here. It's just event that has the type of player join and then an owner. So the Twitch user that wants to join. And then we push that event to TDL and stack. So And then in scenes, in the game scene, we handle those joins. So basically, if the event type is equal to the player join event, then we call on player join, which is here. And first, we want to check if the player hasn't already joined. That means we check every player in we can find in the entities list. So get every object in self.entities if that is an instance of the player. And yes, and if the owner of the event, so the player that wants to join, is equal to the name of the player already in game, then we break out of that loop and do not join the player multiple times. But yeah, this Python specific notation. So if we do not break out of the loop, so kind of go through the loop uninterrupted, then we call this else statement here, and this will create a new player entity with this owner. Health 10 at this position and foreground color, and then we append this player. This event owner is just the character that represents the player object. So this little p or your j. So then if we append that to the entities list, we should have. Okay. So this is the entities module. So each entity is a game object that has those engine specific interfaces, and an entity then is just or adds to that a character, position, and foreground and background color, and knows how to draw itself to the console. And the player then has also a name, maximum health, draw code. So this draws to X and Y, a character, foreground, background color. So tactically that should be correct, but maybe it's the console, the wrong console. We're on to. So we append this player. Yeah. So and then in the base class of the scene we have this draw code. So we create a scene console, the same dimension of the scene. Then we draw the frame. So the window frame. I need to refactor that into the UI, or regan that, and then the window class, and then this is easily set up. But for now, yeah, we draw the frame and header and the footer text. Yes, that draws then to the console, and we split that to the console. And then we create another console that has dimensions -1, the original scene. This is basically to transform the coordinate system of the level and the characters to 1-1, so that the borders of the scene do not overlap with the level. And then for every entity, we draw to the scene console, and then split that. Oh, did you move to the left? No, you did move right. Oh, no. Just let us start it again. Oh. Okay, so there you are. Can you move around? Maybe down or right? Ah, okay. That worked. I don't know what the problem is. So we don't have collision detection hooked up right now, so I can go up. Oh, maybe I. Ah, okay, no. um, I moved up, so we went into the frame border, but I also moved you as well. So I actually don't have that hooked up right now. So if I do that, yes, okay, yeah, that explains it. Right, cool. Yeah, so that's definitely something we need to sort out. Yes, so when we move something, we do have this chat event here. We map the directions to actual coordinates in our coordinate system, and then we push an event, player move event for every direction, and we input it then to the DDL event stack. So, and this event just has a type of player move, owner. This is we have to check, and then the direction we want to in. So in this entities module here, we actually have to check if we are allowed to move. So if event type is that of player move, and also if event owner is equal to self.name, then we can append those move action. Right. Players should ignore moves they don't own. Actually, events in general that aren't theirs. Yes. So yeah, that is exactly that's the problem. I think that is now sorted out. Okay, so try that again. Nice. Okay. Yeah, thanks, Joshua, for helping me debugging that. Okay, nice. Yeah, something I forgot to implement. All right. No, the leave command is also not hooked. All right. So, next thing. Next thing would be to have an actual level we can move around to have collision detection with. No, it's actually quite helpful to backseat programming because I mean, you know that yourself, but if you stream, you think differently. Sometimes you are really blocked, and then you. It's good to have someone watching you. um, okay, so it would be great to have a level we can move around to have collision detection with. This is something. So let's create a new file. Level file. And that is not an entity because it has no character, but it has a matrix of characters. So we let that inherit from GameObject. Should be the best thing to do. So for entities, and then we have a level GameObject. Yeah. This has no position because it lives in the scene object. Now it should have a position. Okay, now I have to think about that. That's all for now. Okay. So the level consists out of tiles. This is a list, just a pair. We can initialize this. Oh yeah, of course. We also need a width and a height level. Height. Yeah, it actually doesn't need a position. Because we can issue the position when we draw to the console if we did. Yeah. So width and height. Then we have those tiles which we need to create. So tile, which just has a type, tile type. Then we also have to create a tile type object. It just stores identifiers like none and maybe all. And we can predefine those. So let's say tiles. That is dictionary with the tile type name. So tile type none and then tile type 1, and that needs also a character and maybe a color also. So character, foreground color, background color. Yes. Then we have also the tile type wall, which is a tile type wall. Has a character of hashtag foreground color white. Also can refactor that to a colors colors file. And none, let's just take the dot. Okay. It probably is implicit 0, 0. The level, if we build console, yeah. Maybe yeah, we have to check on that. Because if that works, we have this implicit coordinate transformation. So we don't need to basically apply an offset to all the entities, to their positions, when we draw them to the screen. Just really nasty. Okay. So we have the tile type. We have a definition of tiles, and then in this init method, you can say for y in range self.height, for x in range self.width, I just want to randomly populate this array. Random. Let's say yeah, let's do it that way. If random dot random 1, right, is smaller or equal 25%, then we create a wall. So tile is equal to tiles tiles wall, and otherwise the tile is at none. Yes, and then we also need to apply that. So we have the tile and tile. That's the level. To call that. And then we also need to teach the level how to draw itself. If we have the draw method, so self.console. You can do it with the list comprehension. Those things here, yes. Yeah. And now we can do that. basically the tiles. No, it should be something like this. We have x for x in range, blah blah blah. Actually, we have x and y. X and yeah. We also need to wrap that up in a. Oh, I can't think about that now. Let's do it another time. Okay, so back to the drawing. I will just so maybe this is the critical point that we need to create a console in the scenes. Because we don't know where to. Yeah. So the thing is, when we draw the scene or the entities. Okay, no. So we create a custom console for that. So we not drawing to the root console, but to a custom console that has specific dimensions, then is splitted at specific positions. So actually, exactly what we want, and we can just draw to the console. One of random. Oh yeah, okay. Yeah, see, and then we can route that through the dictionary of tiles, right? Yeah. So you basically need to replace the 1 and the 0 by the tile types. Yeah. Mm. I say that. No, it's okay. Okay, so we already have that console, which is correctly set up in dimensions and coordinates. So we just need to draw the content of the tile. So console for. There are also methods like draw rect and frame built into TTL, but I don't think they will help us here with this custom content. So just draw the characters. We also could create strings of every row, but I don't think that would be much of a performance boost. I don't know. With the character. So guess this X and Y, and then the character. First need to have the index of the one-dimensional array, so that is x plus y times, right? And then we have self.tiles at the position I tile class. Then we use the character and then also the corresponding foreground background color. Oh yeah, the string will wrap. Yeah, you're totally right. Is then more efficient, so we don't have to do this loop, right? Yeah, we can try that out later. Okay, so we are drawing to the console this character corresponding tile. Okay. But I can make a note here. Wrap. Oh, we init the thing. We taught them how to draw itself. We find the tiles. So what is left to do is actually to hook that up in the scene. So in the game scene, to create a level. For level, level is equal to level. Oh no, naming. Level is also the name, the import of package. L. Level that needs a width. So that is actually self.width. Oh, no, I don't. Dimension, it's dimension. I changed that. I used width and height, but I changed it to this dimensions variable. And that's it. So we have this level. The level inits itself. Just have to append that to the entities. Self.entities append.l. So you give that up with the names here. Yeah, so some guys do for modules every time name cast underscore and then the module name, or yes, M for module stuff. But that way I think it's more clear. Okay, so we added the level to the entities, and yeah, can give that a try. I guess we're running an issue for the rendering order, so maybe the level is on top of the players. So we might sort that out. But let's give that a try. Errors we make. Oh, ooh, ooh. That seemed to work. Nice. Okay. Yes, the level is added first, but when we later add power-ups, where they should always, no, the players should always stay on top. So what we then basically need to find is a render layer of some sorts, and then when we draw all the entities here, the entities, we need to sort them, basically giving them a render layer, and then we can say sorted entities, basically sorted set of entities, and as a key use render layer. Yeah, and then UI, we give UI the highest number and the player the lowest, so they will always stay on top. But now I want to implement the collision detection. Yes, a z-sort property. Yeah, that's what I mean with render layer. Okay. So yeah, but in order to have the entities have proper collision detection, they somehow need to know level is. To know, they need to communicate. Need to be able to communicate with the scene. Scenes. And then the game scene instance. Well, here we can say if not games instance. No. Instant games. Oh. Should they know about the level or some manager that handles collision? Yeah, I think they don't exactly need to know the level. They only need to scene, and the scene can handle as a sure, maybe. And yeah, and for the handiness, we don't need to search for the level, or every time the entities list we can say level equals level, so we have a level property that stores the reference to the level. I don't know, does it? So every entity has a reference to the level object. Yeah, I think it doesn't really matter. Yeah, you have a singleton object, yeah, right. Yeah, so I implement that for the game scene. I have the global instance. I guess if you wanted really to have singleton, then you have to override the new method. But the reference to several top entities. Yes, genau. Yeah, right. So this is then why I keep a reference to the level itself. Singleton-ish, yeah. So I guess there is something like a new method that is called in advance of the init. Yeah, but I think that approach here handles that just fine. So then we need to define methods for collision handling. So yeah, just say check collision with level, and we need a position to check for. Yeah, and we collide only with the walls, so also need to import it. Oh, we also already have the levels, so and say tile types collide with level dot tile type wall. Okay, this is the wall for now. Then we need the index of the one-dimensional array. So again, position zeros. Oh yeah, position 1, and we don't need to calculate the dimension again. Here we can just the level with that. So, and then if we'll just return that's okay. Return of.level tiles I in tile types to collide with tile type. What do you mean that I'm not sure of? What exactly? What do you guard against? The singleton thing? Oh, the new operator. Yeah, yeah. I've never used that, so I'm not sure about how to use that. Yeah, is there a huge stream delay? I don't know if I can do something like that. Sorry. Yeah. So and then yeah, we return not right. So I want to return false if we do not collide and true if we collide. So if self the level tile type is not in this one, so if it is on not a wall, then we return. Wait, if it's a wall and it is not. No, that should right. Okay, 5 to 10. Yeah. Okay. Do you have a better suggestion? Slivers. Yeah. Okay. Slivers. Yeah. That's so we can hook that up in the players air class. So right here, when we do the tick. So if there are actions left, we choose the next action, delete that, and then we perform the action. Maybe we should check collision here. Action. Collision object. It basically tells you who collided with. Yeah. Yeah, I wanted to separate that out. So then also have a method does something. Names are so hard. I don't know. Check for is colliding with entity. Something like that. Is tile occupied? Yeah, okay. Right. Too much engineering for this one. Yeah, maybe. If we want to do that in one. But then we also need to, well, we then would have basically something class collision object that has owner and target maybe. I don't know. The target would be an entity. We hit another player or item, but if we collide with the level, this would just tile type. Yes, the collision. What I want to do, yeah, so we have this move action, which actually then performs the movement. So it has an owner, and then it just applies this direction to that. We could need to check the collision before moving. Or Then have something like the target position. All of this. And if not game scene instance scenes, game scene instance of that scene. So it's something like that. If we have a solid part in the level at the target position, then we just do on the action, and otherwise we if the given tile is not solid, allow the move. Yes. Yes. Exactly. So if it is solid, then disallow it. Maybe also could say if not solid, then do the movement. Okay. So let's try that out. So I join, right? Then I move right. Okay. What happens? I'm gone. Oh. Can you move? You moved, but there's no movement. Okay. So we want to get to the target position, which is just the position plus the direction we are heading to. And if not scenes, can see. Yeah, I think something is going on with here. We have type here. Yeah, we can reverse the logic. Oh, okay. Okay, that's weird. Did I make right? So I made a logic error here. Um, so is level solid? Oh yeah, I guess this not is correct, right? So this returns true if are in. So this returns true if the tile type is all. Yeah, I had that switch because of the naming, initial name. Okay. Yeah, I'm 1 hour in the stream, so I think I wrap it up here. Just keep it. Oh, I think it didn't terminate. Yeah, it's still here. Kill it. Okay. Yeah. Oh, did I? I can't find that out. Why aren't we moving? Are we colliding with each other? That shouldn't be a thing. Dang it. Yeah, I think I switched. Right. Yeah, sure. It shouldn't be solid. Yeah, thank you. So it's sorted. Yeah, beautiful. But we don't check for going out of bounds, right? Oh, it's actually already handled. Sorry, I closed it out. Shouldn't that actually throw an error? Yes, the index. Here, right? So, should get index that is not in the list. So what we could do is to restrain that between 0 and level that with wide. But I wonder why didn't that give error? Oh yeah, I'm checking one dimension error array, and if this is index 0, and if I want to go here, this is -1, just basically that. Okay. Yeah, and because it's metric, we actually check for the opposing wall. Yeah. Okay. Hmm. Yeah, maybe to make it really right, we should. I'm out of time. Yeah, maybe. Yeah, if you go up or down, or check the position, right? Um, but for the position, which coordinate system is it? Um, no, it's a level coordinate system. Right. So I could say if position 0 is smaller than 0, or position greater than self.length with 1, or position greater than self.length height -1, then we just. And none is also false, right? So then we should return like so. Yeah. Oh. Oh yeah, yeah. You're thinking the other way around, right? Greater 0, smaller. Yeah, it doesn't matter. It's just the opposite. Yeah. left. It works, so. Oh, you are in a really bad spot. Okay. Yeah, eventually we could use. Yeah, so my plans are that we have this random level layout. Maybe have those walls here which are indestructible. Then maybe rock between those. The rock can be destroyed. And there you, in some rocks, you can find a weapon or a power up, so a bomb launcher or a laser gun. They then just will have an area effect or pathway that they create, and every player in areas of damage then will hurt. So, um, that maybe it's interesting. The whole the problem is, of course, you have a turn-based character and a play, and then yeah, maybe in the end it's not as fun as I think, but let's see. Hey, rejected byproduct. Up. We're in the middle of creating a Twitch playable competitive multiplayer game entirely written with Python. But unfortunately, I'm already at the end of my stream, so this is how it should look like, or maybe. Yes. Yes, I decided to try that out. Yeah, right. Cool. So actually, we could save some of those things to out. Twitch chat manager on scenes, also level, game, entity, app. Don't have animations yet. Have actions. So, and then we can say something like adding initial version game. And we push that. The turn delay is an interesting design challenge. Yeah, it is. But you can have then also power-ups that can increase or decrease your speed. So you take half or tick. Because I plan on having power-ups that you don't know the effect of. So they can have bad or good effects. That's the thing. Okay, so we save that to the cloud, and yeah, I can once again pull that up. So if you want to join, just type in join. You can move around. The move command. All right, so yeah, I will wrap it up here, and thank you for watching. And I think tomorrow I will do a Dark Souls stream, and then next week we program a little bit. But I'm not sure about the schedule. There are things that change this month. Then I'm more confident in having a more strict schedule. All right then. Bye bye.